All right, in the previous video, we watched or we learned how to do the first part of the quadratic formula, and that's the part under the radical. Remember, we call that the discriminant. Now, all that tells us, though, discriminant just tells us how many solutions the problem's going to have. It's not, and what type of solutions those are going to be. But it doesn't tell us what the actual solutions are. So to find the actual values of those solutions, we're going to use the rest of this discriminant of the rest of the quadratic formula. So that's what we're going to be looking at today. So let's just jump into it. Now remember, what we're doing is we're working with equations in standard form. So when we have something in standard form, this is a form we're dealing with. So when you hear me talk about and reference values like A, B, and C, we're talking about the coefficients, the numbers attached to those values, and then the C is our constant. Now the first step in doing this is always make sure that the quadratic is equal to 0. So these first couple of examples, you can see that that is the case. Let's see how we would use the quadratic formula then in this first one. So in this first one, we have, again, the quadratic formula. I don't know why this isn't staying, but here we would have x equals the opposite of b. Now notice what I just said there. I said the opposite of b. Why did I say that? Well, we have the negative b. Negative b, if I just said negative b and the value is already negative, a lot of times people then forget what to actually do. So in this case, since it's negative b, I want you to think of it as the opposite of b. Oops. All right, so the opposite of b, so the opposite of negative 4 would be positive 4. This would be plus or minus the square root. Now, negative 4, when you square it, becomes a positive 16. And again, notice what I did. I didn't write down negative 4 squared. I squared it in my head. Please do that. Do not write down negative 4 squared. If you do that, chances are you're going to type it in the calculator wrong and get the wrong answer. So go ahead and just square the b value in your head. Negative 4 times negative 4 is a positive 16. And then let's write down the rest of it. So then it's always minus 4 times a, which is 3, times c, which is negative 9. And all of that is divided by 2a. A is 3, so 2 times 3 would be 6. Okay, so the next thing we're going to do is we're going to find that discriminant. The discriminant, again, that's what we talked about in the previous video. That's just where we take and find the value underneath the radical. So if you did that on your calculator, you're going to get 124 as your answer. All right, now we do need to simplify this. So the next step is if we can simplify what's under the radical, we need to simplify that. So the square root of 124 that simplifies to be, find what two numbers multiply together to be 124. Well, if you said 2 and 62, that's fine. We can use 2 and 62. 2 is prime, and so I'm going to continue this on. So I'm going to find another pair of numbers that multiply together to be 62. You might say 2 and 31, and 2 is prime. 31 is also prime. So these are what we call the prime factors of 124, the three numbers that I have circled there. So now the way that we're going to do this is for every 2 of the same number, we're going to take one out. So since I have a pair of 2's that are the same, I get to take out a 2. The 31 does not have anybody to go out with, so that's going to stay under the radical. Now before we can move on from this, we need to make sure that we have this simplified. So what I do is I look at all the pieces that are outside the radical. So what's inside the radical we don't touch. It's protected by the radical. But outside the radical we have a 4, a 2, and a 6. So we want to see are each of those values divisible by? And each of those values are divisible by 2. All right, so when you divide each of those by 2, we end up getting our final answer, which would be 2 plus or minus 1 squared root of 31, or just say 31, all divided by 3. So those would be our solutions. Now remember, that means we have two solutions, 2 plus the square root of 31 divided by 3, and 2 minus the square root of 31 divided by 3. All right, let's look at the next one again. Let's look at this one together. So for this one, we have, again, if we start it up, it's going to be x equals the opposite of 9, or opposite of negative 9, which is 9, plus or minus the square root Again, remember what I told you last time. Square the negative 9. Write it down. Negative 9 squared is a positive 81. Minus 4 times a, which is 1, times c, which is 27. All divided by 2a. This time a is 1, so 2 times 1 is just 2. Now remember, next thing we're going to do is we're going to find the discriminant. To find the discriminant, or when you find your discriminant, again, do that on your calculator, we get a negative number. We get negative 27, all divided by 2. Now, at the beginning of this chapter, we learned about the square roots of a negative number. Remember, the square root of negative 27, let me write that over here so you can see it, is the same as the square root of negative 1 times the square root of 27, which means the square root of negative 1, remember, is I, and then we have the square root of 27, which we'll simplify in just a second. Otherwise, a really easy way to simplify this is to put an I out in front and then make that positive. It's essentially what we're doing. So now we can simplify the square root of 27. So that breaks down to be 3 times 9. 3 is prime. 9 breaks down to be 3 times 3. So this would be, since we have a pair of 3's here, we can factor a 3 out. And then along with the I, so we'd have 3i out in front. We're left with a 3 under the radical, all divided by 2. Now that cannot be reduced anymore, so that's your final answer. So that's what to do if you have the square root of a negative number. You take an I out and make what's under the radical, you make that positive. All right, so these last three are very similar to the ones that we just worked on. Now, if you notice, though, with these two, you need to make sure that you get it equal to 0 first. Let's look at that last one, because it's important that when you get it equal to 0, again, that's talked about right here, that when you get it equal to 0, ignore the bell, we want to subtract it from both sides, but you also want to make sure you put it in the right order. So you want to make sure that it's in standard form. All right, so I want you guys to work on these three now on your own. And so pause the video and hit play when you're ready to check to see if you've done them correctly. All right, let's see how you did. Let's start with this first one. So this first one, it's slightly different from the other two because when you find the discriminant, the part on the square root, you get 529. Now, anytime I do a problem like this, if it's a number I don't recognize, I always test it on my calculator first to see if I get a decimal as my answer, because then that'll tell me if I need to do a factor tree or simplify that. But if you do the square root of 529 on your calculator, you get 23 as your answer. So again, I don't expect you to know that off the top of your head, but your calculator will give that to you. Now it's 23, it's not the square root of 23, so you just write down 7 plus or minus 23 divided by 12. Now those are like terms in the numerator. So notice I have these arrows bringing us down here to the next steps. So there's two ways you could, or there's two answers that we're going to get. One when we take 7 plus 23, and the other when we take 7 minus 23. And again, those are like terms, so that's why we can simplify this to get 30 over 12, which reduces to 5 halves. And 7 minus 23 would be negative 16 over 12, which reduces to negative 4 thirds. So that makes this one different from any of the other ones because we can actually take the square root of our discriminant and get a nice integer, and we don't have to simplify. All right, so let's look at this one. So you should get negative 3 plus or minus the square root of 3 over 2. How do we get that? Well, our first step, again, we want to get it equal to 0, so we add 3 to both sides. And once we get that equal to 0, then we can set up the quadratic formula. Now, underneath the radical this time, you get the square root of 12. And that's been simplified on the right there, so you can see the square root of 12 simplifies. So we have a pair of 2's. So those pair of 2's, we get to take 1, 2 out, not a 4. Don't multiply them together. For each pair, we write 1 outside the radical, and whatever remains stays under the radical, which would be the 3. So I'd have negative 6 plus or minus 2 square root of 3 over 4. All the pieces outside the radical can be divided by 2. So we go ahead and simplify this. Negative 6 divided by 2 is negative 3. 2 divided by 2 is 1, so we'd have negative 3 plus or minus 1 square root of 3, or just leave it as square root of 3. And then don't forget to divide our denominator by 2 as well. So we get 4 divided by 2 is 2. Now the last one, I'll just scroll to the bottom here. You should get you get 2 plus or minus 4 square root of 5 over 6. Which, oops, I just remembered. I didn't get finished with that one. That can simplify further to be 1 plus or minus square root of 5 divided by 3. So that would be your final answer for that one. Now let's see how you get that answer. So this one, we started it out together. Remember, we subtract 2x. Make sure you put that in the middle. So it'll be 3x squared minus 2x plus 7 equals 0. And then we set it up with the quadratic formula. And the discriminant this time is negative 80. Now I simplified that because remember, I told you before, if we have the square root of a negative number, we can't take the square root of a negative number, so factor out an I and make what's underneath the radical, make that positive. And over on the right there, I've done the factor tree for us. So 8 times 10 and 2 times 4 and so on. Now you didn't have to do 8 times 10. You could have done it with any pair of numbers and you'd still get the same answer where you'd end up with 4 2's and a 5. Now again, it's a square root, so for every 2 of the same number, we take 1 out. So we have a pair of 2's, take out a 2. Another pair of 2's, take out another 2. And we're left with the 5. And the pair of 2's that we have outside the radical, multiply those together, so we get 4 square root of 5. Whoops, I forgot my I. So it'd be 4i square root of 5. So our answer would be 1 plus or minus I squared of 5, all divided by 3. So that's how you do those problems. So hopefully that made sense to you. And good luck now as you work on your assignment.